Assalamu alaikum. Our group is in charge of monitoring the quality of a tablet production for a particular type of a tablet. This tablet, the Billaracha Kuliriasi, this is the tablet characteristics. This is the weight. This is the relative density, and this is the tensile strength in megapascal. And in this data, there are three shifts: the evening shift, the morning shift, and the night shift. So we are going to analyze these data. This is the number of beans per shift. So in the evening it is 71 beans. In the morning it is 61, and at night it is going to be 68. And the total grant is 200 beans. So as we can see from the graph here, the evening has the highest number of beans, and the night has the second highest one, and the morning has the lowest one. So the next thing is to calculate the sum of the weight. So the first thing to calculate is to calculate the sum of the tensile strength in megapascal, and the next thing is to calculate the sum of the relative density, and the last thing is to calculate the sum of the weight. So as we can see, this is the total grant for the sum of the tensile strength in megapascal, and this is the total grant total of the sum of the relative density, and this is the grand total of sum of the weight. So as we can see, and this graph, the gray one is representing the sum of the weight, the orange one is representing the sum of the relative density, and the blue one is representing the strength in megapascal. So the second thing is to calculate the average of the tensile strength in megapascal is going to be this number, 7.152, and the average of relative density is going to be 88.139, and the average weight is going to be 349.143. So and this is the total, this is the grand total. So as we can see, there is not that much difference between the shifts in terms of the average. For question B, basically we are going to make hypothesis test on the tablet to check whether the tablet is following the normal distribution of 350 milligram and the standard deviation of 14 milligram. From this data, we got the total size of 5.129, and then the total chi square is going to be 11.07 when alpha is equal to 0.05. Since the chi test is less than the chi square, we fail to recheck the HO, and we can see that there is significant evidence that the tablet is following this distribution. For question C, we require to comment whether there is a significant difference between the tablet weights from the different shifts. So in this question, we are going to use the ANOVA. So this method allows us to compare several group observations, all of which are dependent but possible with different means from each group. So the S is representing the sum of square, the DF is representing the degree of freedom, and the ms is mean of sum of square, and the f can be get from ms within group divided with ms within a group. So um, so the hypothesis is saying that all the means should be equal to each other, and for the hypothesis to be rejected, at least one pair of means is different. So from this data, we get an f. So if the f is greater than the f critical, and then we will reject the HO. Since the f is less than the f critical, we fail to reject the HO. So there is no significant difference between the tablet weight from different shifts. And the top table is just the summary. This is the count that we made before, and then this is the sum, and this is the average, and this is the variance. For the last question, we need to determine the prediction of the table when it has a low relative density values of 68%, 74.3%, and 80.1%. So in this question, we are going to use the linear regression, and from these data there are two important numbers. So one of them is the intercept of the coefficient, and the other one is the relative density coefficient. So from these two numbers, we can come up with this formula, and then we can plug these numbers into this formula, and we are going to get the predicted tensile strength in megapascal. So as we can see, when we put 68 into this equation, we are going to get 5.4, and 5.4 is out of range. It's not in this range. It will fall into somewhere here. It also same as when we put the 74.3, it will give us 5.9. It is also invalid because it is out of range, because also it will fall into here. It is same as when we have 80.1%. When we put this number into this equation, we are going to get 66.4, which is also invalid because it is going to be also out of range because it's going to fall into here. So the predicted tensile strength in megapascal is going to be invalid for all of the percentage that has been given to us.